joining this webinar. Thank you all for joining this webinar. The topic of our webinar today is AI application security and the future of software development. As we know, AI is embedded across every stage of the software development lifecycle now, reshaping how applications are built, tested, and deployed. While this accelerates innovation, it also dramatically increases the complexity, specifically to against security and supply chain attacks. So the new challenge is how do we operationalize security, especially in AI-driven environments? What are these key shifts that are happening? And today we will be looking at what are practical execution-focused guides that we can enable in organizations so that you can develop with velocity and with security. Some things that we'll look at are specifically what application security programs will look like in the coming years, specifically with the advent of AI, especially with cloud code security and so many of these new age tools coming out. So, and what are some critical risks and blind spots that can be introduced through AI? And with us, joining us today is Amir from men.io. He's a senior sales engineer at men.io, and uh, I would love to have you introduce yourself, sir.
Many thanks, Rahul. Hi, everyone. My name is Mishmiri. I'm one of the sales engineers here at Mend.io. For those of you that don't know, Mend.io is an application security company that specializes in looking after your code, whether it's the sort of legacy way of creating code without AI, or even the modern day application development, which is using AI natively. So we're here to help you with all of those needs and requirements. And hopefully today we can go through the changes that we've seen and where we see the market heading.
Great. So, Amir, before we start, I have like a very layman question, maybe. So, what is the difference between securing an AI and then securing the code generated by an AI? Is it the same thing? Is it something different?
Wonderful
How do
question, Rahul.
organizations tackle?
Wonderful questions. So it's broken down into two problems, right? First, we've got the problem of AI generated code, which is being created by Cursor, Copilot, GPT, whatever you may be using, you're creating code, right? That is still an application security problem in the aspect of it still needs to have SCA running on it. It still needs to have SAST running on it. So what we've seen within the industry is rather than trying to figure out where the code has come from, treat it as code, scan it, and make sure that there's no vulnerabilities being used by the code that's being created, right? The issue that we face is that the code that's being generated, it typically hasn't had security measures run across it already. So there may still be those flaws, those little vulnerabilities that you need to know about that still need to be scanned and make sure that they're going through systems like SCA and SAST to pick up on these issues. That's the first problem. We then have the usage of AI within the code. So for example, you're using models, you're using AI components. That itself is another level of risk because that's now looking into the actual usage, not the code created by AI, but using AI within our applications. And that in turn also has the same security issues of are they malicious packages? Do we have any security flaws? Do we need to harden our system prompts? It's a new generation of a novel problem. It's very, very similar to the early days of third-party open source dependency usage, right? We're trusting what the market's giving us, and we're taking it on face value, and then we're using it within our applications. We now need to have the methods to scan, make sure that there's no vulnerabilities, and make sure the AI we're using within the actual applications is also secure.
Got it. And where does visibility come into the picture, especially when it comes to this? Because if it's an AI, it's running on the background. You've given them certain permissions. How do we know what it's doing, really?
Fantastic question. That's one of the key problems of 2026, right? We don't know what we don't know. So the first approach of having a new application security program, which we'll go through in the presentation today as well, is having that visibility aspect. What are we using? Do we have an AI bill of materials? Do we understand which components, frameworks, technologies we're using? And if we don't, well, we're opening our doors to potential problems, right? Because we don't know what we don't know. So shadow AI is a super important part of any new application security program. And we need to adjust our programs to take this into consideration now, because it's not something that we did before because it wasn't a problem before.
Got it, got it. And how does knowing what the AI is made of help in detection?
Great question. Once you know what you're actually using, you can then use tooling to scan your actual applications, right? If you know you're using a specific alarm model, for example, and we know that it's got a vulnerability on that, now you can be privy to the issues that that model can produce for the organization. Hugging Face, for example, does a very good job of trying to give you safe, unsafe models, but even better, there's still some gap between the actual data versus what happens in a real production environment. So once you know what you're using, you can start to scan, understand the security risk and the security architecture that comes with the usage of all of these models.
Got it. And so what are some of the common countermeasures that, as organizations, once they understand and they start off on the journey, what are some countermeasures that uh, one can implement?
Yeah, so obviously, if it's a malicious model, it's been created by design to cause havoc. Straight away, stop using that model, right? You don't want to use something that's been created to cause problems within applications. If it's simple problems or novel problems, such as the system prompt needs to be hardened, or you need to tweak the instructions you're giving to the models, or you need to use different versions of components, we at Mend.io help you make these recommendations and obviously have the ability to be able to move forward. There's not a one size fits all, right? As you'd imagine, because each use case is different. But we try and give as many countermeasures as we can, right? Hardening your system prompts, making sure that you're running pen testing, so red teaming on demand, and scanning these models as and when you need to. So we try and give you as much insight and information as we can so you can make the best decisions possible.
Got it. Got it.
Fantastic. Righty. Should we jump into the presentation for today?
Yeah, let's do that.
Fantastic. All righty. So, team, thank you so much for joining today's call. As you can see, what we're going to go through today is securing 2026 from strategy to execution. Now, the three major changes that we've seen when it comes to application development in the world of 2026 is around the way that we're using AI, right? AI has now become a code producer, right? We're no longer creating code by ourselves. We're starting to use tooling, we're starting to use models, Cursor, Windsurf, whatever it may be, to start to create the code that we're using within our applications. And as we just discussed, that can have its own ramifications and problems. So we need to make sure that we're looking after the aspect of the code that's generated by AI. We then look into how AI can become a part of the attack surface. So can we actually exploit models, chatbots, agents that we're using within infrastructure and actual organizations to potentially have backdoors into our organization? So now that we're using AI, we need to protect ourselves from AI, making sure that we haven't added a new surface layer that we can actually be attacked on. And then finally, we have the speed of actual security problems, right? AI creates code very quickly. We know this. So that also inherently means that security risks can be created very quickly. So now we're at a time where, because of AI, we're seeing more and more security vulnerabilities pop out at a rapid rate. And now we need to actually make sure that we've got the measures and means to be able to protect ourselves from the actual security issues that are being created by AI. So what we're going to look at is what's changed, the challenges, and obviously I'll give you some suggested strategies and tactics so we can have some concrete items to move forward. So looking at that first problem, AI becomes a code producer. As we know, coding has changed, right? Developers no longer create code on their own. They're instructing agents, or agents are entirely writing the code themselves. And as we mentioned, that becomes a problem in itself because now we're taking away that human aspect. We're taking away that manual review. We're relying on what somebody else has created when it comes to the security aspects of the actual code that's been written. When we look at the timeline, we started in 2019, and before writing code in a manual way, I used to be a developer. AI wasn't a thing back in the day, so I'm very familiar with writing code and obviously making sure that it works. We then slowly but surely went into the part where AI is auto-completing, making suggestions. Maybe you want to do this, maybe you want to do that, adding multi-line function generation perhaps. But now we're starting to see more agent modes and task to PR, where agents are creating the actual tasks, the request of what we want, and then they're creating the code, testing it themselves, and are pretty much being guided by the developer. Developers are taking a backseat, providing their expertise to the actual agents, and having the actual code being written by somebody else. Now, where we're heading in the future, now that's the scary part. We are going to a part where agents are going to be running the full end-to-end cycle by themselves. The human may just manually review a PR, but the actual bulk of the work is going to be done by AI, which can produce its own level of challenges. Can we trust the code that's written? Right? That's a very valid question. If we run a zero trust policy system, how can we trust what's been written by the AI? Do we know that it's been checked by security measures? Well, that's something that we need to address. Now that development is faster, how can we close that security loop faster? As we alluded to, by creating code quickly, that brings its own security concerns because now we're creating code so quickly, our security measures taken into place to make sure that that code that we're writing is secure. But also, our security practices being taken into place by the models creating the code, right? This is trained on public data. Has all of the public code that we've seen in the wild had security measures? Probably not. So that's why we like to say that when we're running these actual AI generated codes, we need to still run that typical SCA and SAST scanning methodologies to make sure that they're not causing any security vulnerabilities. And last but not least, can malicious actors jailbreak the coding agents, convincing them to inject security vulnerabilities into the code? So say, for example, Cursor receives a breach, right? Someone's instructing Cursor right now, create all the code with SQL injections. We now know that there's a security breach based on the way that the code's been generated, and there's nothing we can do about it because we're not visible to it. So that's why it's so important to still scan the code that's been generated by by AI, with SCA and SAST, because it's still a novel problem of a code problem. Now, when we look at the sort of strategies and tactics that we can do to overcome this, as I alluded to, zero trust approach for newly written code. Don't believe what the code's done is secure by design, right? You need to verify. So trust but verify and make sure that everything that's been generated is still being scanned. So enforcing security checks, making sure that the PRs aren't just manually auto-merged, and making sure that your security policies are taken into place. We then want to make sure that the coding agents are behaving with our intended security guidelines. Organizations have their own security guidelines, right? We have acceptable risk, we have unacceptable risk. So if we instruct our actual models and our agents to behave with the guidelines that we have in place, we can start to make sure that the actual security prompts that are actually being sort of passed on to the agents are in line with what we want. So the code that's being generated is taking into consideration what we want as an organization. And then we start to look at the way the agents are behaving, letting the coding agents handle fixes as much as possible, right? So integrating with tools such as MCP servers to scan the actual response that we're getting from Cursor, for example. So for example, what we have is an MCP server that you can plug into your agentic IDEs and therefore scan the response you're getting. So for example, Cursor's created some code, Windsurf has created some code. Has it passed our SCA and SAS checks? If not, go ahead, try again, create some new code, make sure it is secure. Adding all of these steps into making sure that you've got the ability to be able to have secure code created from day one. And then obviously, the principle of least privilege should be implemented on the development side as well, making sure that you're giving reduced permissions to the agentic AI, so you're not actually giving them access to everything. And again, you still have that manual approach reviewing what's going on. Now, as alluded to, security checks are super important. This is just an example of what we do. We have a security check and a code check that can be done on the PR level. So once the agentic code has actually created the actual PR, we can scan it, make sure there's no vulnerabilities, right? Giving you that SCA and SAS that you still need for the agentic code. Here we can see example within Cursor where you can start to set up rules. You can see we've got specific security rules that we've got at the bottom there that give you the ability to be able to make sure that you're connecting, let's say, to an MCP server, or we've got specific rule sets that you've deployed within your agentic IDEs to make sure they're following those security practices. And as I alluded to, we've actually got the ability to be able to run those security checks. So by connecting to our MCP server, we're going to verify those responses. And then you can see we've got two steps that have been kicked off: the Mend Code Security Assistant, and then we've got the Mend SCA Security Assistant as well. What that's going to do, scan for SCA, scan for SAS, and make sure that they are actually picking up on the issues once the code's been generated. So again, trust but verify, make sure that the actual agents are behaving in intended ways, but also have security measures in place so you can verify that they are working in their intended ways. Now, when we look at the second problem, we see that AI becomes a part of the attack surface, right? We've got all of these new technologies that we have to deal with. We've got the inference providers. So whether it's Claude, whether it's ChatGPT, or whether it's OpenAI, whether it's Hugging Face, we've got models, notebooks. AI is being used everywhere. You can't get away from it, right? But now that provides you with a new layer of security problems. We've got all of these different technologies that can now potentially be exploited and cause security violations within our organization. And that led to the creation of such as the OWASP Top 10 LLM vulnerabilities, right? To look for these problems to make sure that we can pick up on them, right? Whether it's prompt injection, whether it's improper output handling, or whether it's outbound in consumption, there are now governance and sort of compliances in place to help you pick up on these. So we can see that it is becoming a real big problem, because if you just take a look at the news, You can see many a news article that explains exactly what the ramifications of not following secure coding practices are, right? Not looking after our AI agents or our AI technologies in the correct way. For example, the hackers have hijacked Google Gemini's AI just with a calendar invite. So prompt injection is taking place because our agents are connected to our calendar, right? These attack surfaces are growing. It's no longer we're just going to exploit by connecting to a website, doing an SQL injection, looking for sort of bugs within our code and trying to exploit it that way. We now have to worry about how we're actually using AI and the ramifications it can have for our actual organizations. Now, AI agents, we've got the jailbreak problem, right? Attackers may inject malicious prompts through online resources. So again, if we're using an agent and it's looking at all of these resources, right? If you're asking your agent, oh, go and grab this information from this website, go and look at this email from here. If an attacker has now sent an email with a malicious calendar invite, a malicious prompt, and we haven't protected our agent from this, we've now just created a massive backdoor into our organization because our agents aren't secure by design. So you need to make sure that we're not only protecting our agents, because if we're connecting it to our infrastructure, which a lot of organizations are doing so far, right? We're using them to be able to help internal resources, connect them to our, let's say, internal databases. We've now got to make sure that that agent is behaving in the intended way when it comes to its security posture too. And this is why you've got loads of AI regulations popping up. For example, in the EU, we've got the EU AI Act, we've got GDPR, we've got the Cyber Resilience Act there as well. We're becoming more and more privy to the issue that AI can cause, right? It's becoming more of a prominent problem, and we need to do something about it to make sure that we're not causing problems for our organizations, but also we're staying compliant when it comes to regulation. Now, some of the challenges we've seen is obviously the compliance and regulations around AI models and chatbots, right? You want to make sure they're working in the intended ways. They're not leaking private information, personal information, for example. They're GDPR compliant. So this is why these regulations are in place. This is why, for example, the OWASP Top 10 LLM has been designed to make sure that we've got those measures in place so we can actually measure what we need to do versus what we are doing. We need to look for issues such as prompt injection, denial of wallet, data poisoning. The landscape is widened, right? We need to make sure that all of the actual measures are put into place for the usage of AI to make sure that we're actually having those organizational policies around the use of AI, right? What do we want to happen when it comes to AI usage? What security measures do we want in place? Because most of the time, we're using AI within our core products, which now means that our customers need to trust how we're securing AI within our products. So it becomes a wider problem. It's not just an internal problem. Customers are going to now ask you, how are you protecting us from the usage of AI? How is our products using AI? We're purchasing this tool from you. What are you doing to make sure that it's not going to leak our information? All of these new measures have to be taken into place now. But obviously, you've got the legal and business implications as well of the output of your AI chatbots. You need to make sure you're measuring the output of your AI chatbots so it's behaving in the intended ways. You can't just trust AI. It can have hallucinations. So you need to make sure that it's working in the correct way. And you can run red team against it, which is essentially behavioral risk analysis to do that. So when we look at some of the strategies and tactics, they're quite simple ones, but they're quite powerful, right? We need to stay on top of any AI usage within the company. We need to maintain an AI bill of materials. Myself and Rahul mentioned this earlier on, you don't know what you don't know. So how can you protect if you don't know what you don't know, right? So having that AI bill of materials of what we're using, models, agents, inference providers, tools, whatever we're going to be using, we need to know what we don't know right now. Then we can have enforcing policies on top of that, the governance piece that's missing, right? What's acceptable? What's not acceptable? We can't just trust what we've got there. We now need to say, based on security, what's okay with the actual usage of the different AI materials. Once we've understood what we've actually got, we can identify all of the risks of the chatbots and LLMs within the organizations. This is the easiest way for people to enter the actual organization if we have a chatbot, right? Because there's direct communication between an agent and the end person. So now we've got an added layer of risk there. So you need to run LLM red teaming to make sure there's no jailbreaks, biases, hallucinations, but also have time-based quarterly security reviews of the AI agents. They're always adapting, right? So a fix today may not be a fix tomorrow, but it definitely might not be a fix next month, right? So you need to make sure that you've got the approaches to make sure that you're picking up on issues as and when they pop up. And last but not least, we've got to mitigate the risks, right? Harden those prompts, the actual instructions we're giving to the models. Make sure that the instruction is secure so the model's behavior is secure. But also adding guardrails where appropriate, right? Monitoring the actual interactions between the models and the end user. Are they working in the way that we need them to? Now, AI inventory can be automated. That's something that we do here at Mend as well. So we actually give you the ability to have an AI bill of material generated off the back of an SCA scan. So you don't change anything that you're doing. You're still scanning for SCA, but now we're picking up on all of those AI technologies so you can have full visibility into the actual inventory of what you're doing. So shadow AI is no longer a problem because there are tools out there that can help you do that. Once you've actually found out what you're using, this is where you have the policies to essentially have the enforcement before the actual code is merged. So again, as a part of the scanning process, we now know what we're using on the AI front. We now have our security measures in place. Let's check those before any code is merged to the actual repository and make sure that it works in the correct way. And then we've got the red teaming aspect, right? That behavioral risk. How is our chatbot working in the wild? We need to simulate production attacks on the chatbot to see what it would do. For example, if I give a response, what's my actual assistant going to give as an answer to that, right? What's the actual interaction that we're going to have there? Are we going to give out information? Are we going to give out our prompt? Are we going to be susceptible to prompt injection? We really need to know what we don't know and test our chatbots to make sure they're working in the intended way. And red teaming is there to do exactly that and make sure that we're picking up on all of the issues as and when we face them. Now, when we look at our agents, as I alluded to, we need to review their workflow, right? What are they doing? What are they connected to? What's the actual architecture of the agent's life? What is it being actually tasked out to do and what's it doing in the interim? Is it connecting to emails? Is it connecting to Salesforce? Is it connecting to another model, for example, OpenAI? Does it have an interface between customers? We need to understand how the actual bigger picture connects together. Because we may be deploying these models, we may be deploying these agents and not fully understanding what they're doing. So that understanding piece is paramount to making sure that we can have security policies in place. When I alluded to prompt hardening, obviously models and LLMs take instruction, right? They don't work on their own. They want to be told what to do. And if our prompts are incorrect in the beginning, that means the model is always going to behave incorrectly. So what you need to do as well is A, understand what prompt you've given. So again, scan for the prompts that you have within your actual files. But then B, give you a hardened system prompt to make sure that we're catching these security vulnerabilities within the prompt itself, making sure that you've got the correct sort of prompts within there to make sure there are no security flaws. So when the model's behaving, it's behaving with the instruction that you've given it with security in mind. But then also once it's been deployed, having those guardrails in place, having that observability piece. What are the interactions looking like? What's the agent actually doing? What's it calling out to? Has the user spoken to it in a specific way that we need to block a prompt from taking place, for example? You now need to have these guardrails to make sure that you're blocking sort of malicious behavior where you don't want it, right? Again, visibility is the key here with AI. We need to know what's going on. The third problem we obviously saw is obviously speed, right? Speed becomes the primary security constraint. The time to exploit has gone down massively. If we look at 2019, we've got 60, 65 days to actually exploit a vulnerability. That number is going down just quicker and quicker year by year, right? So by the usage of AI, security vulnerabilities aren't like the security vulnerabilities of 2019. They're coming out like that. If they know that an exploit's available, they're going to create AI orchestrated espionage campaigns to exploit them really quickly, but at a mass scale. So when we look at the challenges, we now need to fix these vulnerabilities fast enough, within hours, within minutes, right? Because they're popping up so quickly, right? Organizations are at risk because we're not being able to move fast enough. So now we need to think out, okay, how can we automate this? How can we make sure that we've got the ability to be able to keep up? So do we fight AI with AI? Probably, right? You might need to have some AI tools internally to help you mitigate the risk. But you also need to make sure that the attack surface is reduced. And again, that all comes down to knowing what you have. If you don't know what tooling you have, how can you protect your tooling? And the final thing is, how can you make it harder on attackers to exploit vulnerabilities within your environment? What tools can we put into place? Can we put WAFs? Can we have runtime protection? Can we have observability, those guardrails we mentioned? So when we look at the strategies and tactics, we need to automate it much as possible, right? Automating dependency updates, whether it's using Renovate, Dependabot. You need to have the approach of that to be able to go through your actual architecture, your actual dependencies and say, okay, I've got these libraries, but which ones are out of date? The latest versions typically have the fixes to security problems. So let's try and make sure we're automating that as much as we can. We want to automate vulnerability fixes. Again, having PRs created automatically. So there's a security problem, bang, here's a security fix. You've got the answers to the problems right away. But again, making sure that the tests are there to be able to pick up on all of these issues. If you don't test, how can you know that you have problems? When we look at hardening the environment, we need to make sure that we've got hardening of container images to reduce the exploit risk, use new compliers or frameworks. So making sure that you've got the most up-to-date versions of frameworks that you're using. And again, using WAS, runtime protection, etc., to make sure the actual infrastructure is safe as well. When we look at that automating piece, as I mentioned, you can use Renovate, which is our dependency hygiene and management tool, which again, its sole purpose is to update your dependencies for you in an automated fashion. Keynote, it's free. So if you're on this webinar today and you want to use something that can help you update your actual dependencies, just go to Mend Renovate and start to use that from today. It will give you a head up on the actual dependencies that are out of date, but also the fixes for the ones that are out of date. Dependable also has the same approach. In my opinion, Renovate's a lot more configurable, but again, both of them are open source. I'll let you decide which one you want to use, but it gives you the ability to be able to understand what dependencies we have that are out of date, but then give you the actual fixes to the ones that are out of date with a PR. So again, that manual approach of, oh, I need to figure out what's going on, which versions am I using, what's left, what do I need to do? That's all gone now, right? You've got tooling in place to help you automate all of this. Fixing the actual vulnerabilities as well, that needs to be done with security tooling, right? So whether you're using Mend, whether you're using another tool, you need to be able to understand exactly what the problems are, but also give you the fixes for those problems. So having automated remediations, having AI-based remediations, right? It's a problem that sometimes you need to use the tooling that's causing the problem to fix the problem, right? Developers can only have so much time to write code. If we've got these new security issues and practices that are in place now, we'll be fixing security flaws forever, right? So that's where you need to use AI-based remediations, have automated PRs, have the automation that you need there to fix the vulnerabilities, to fix the problems. You can't fix everything on your own, right? So make use of tooling to help you do exactly that. So in summary, AI has now become the code producer, right? So we need to now worry about the code that's being created by someone else. It's open source, it's third party, you need to worry about it. Scan it using SCA and SAST. Make sure that you're picking up on those vulnerabilities or have sort of security measures in place with the usage of AI to connect to MCP servers. Scan the code that's been created by the AI. Don't take it for face value. AI has now become a part of the attack surface. So we need to know what we don't know. So if you don't have it already, make sure you're trying to build that AI bit of materials. If not in an automated fashion, just sit down with the development team, sit down with the wider team and understand how we're using AI. What are we using on the components, frameworks, models? We need to understand how we're using it so we can protect ourselves. But also, finally, speed becomes a primary security constraint. Fight AI with AI. Automate as much as you can, right? There are tools in place to help you with this. So whether it's automated dependency updates or automated security fixes, you need to now have the tooling in place to make sure that you've got the ability to be able to fix these issues as and when you face them. Any questions?
Thanks, Amir. That was a very, very great presentation.
Thank you so much, Rahul.
I have a question. So, recently, Google, Anthropic, Claude, all of these guys came out with this paper where they were facing distillation attacks, right? They were so a lot of malicious uh, organizations were trying to get their IP, get all their computing power out through various means. So, like, if organizations like Anthropic, Google are struggling against this, so how can like an organization whose core is not IT or uh, not in this particular realm, like, like if it's like a hospitality industry or
Yeah,
uh, like medicine or something, like how can they effectively deal with this? Like, because if Google can't deal with it, then how can we guys do anything about that?
fantastic question, Rahul, right? And I would say the risk is even higher for the smaller players in the market because we don't have as much resources to protect, right? When we look at the hospitality industry, when we look at these smaller businesses that are running code, we don't have money to have thousands and thousands of pounds or dollars running security measures continuously, monitoring, having observability everywhere, right? So what I would say is go down to the simple things. Understand what we're using, because once we understand what we're using, we can think clearly and say, okay, here is an attack vector that we need to protect from. Automate as much as we can. Use open source tooling if you need to. Use Renovate. Update your dependencies, right? Or even use AI to fight AI, right? When you're speaking to Cursor, when you're speaking to Windsurf, instruct it to create code that's secure. So I want you to think secure in mind. Don't just create code for the sake of creating code. Do it with practices in place to make sure that you're reducing that attack surface, right? And it's these measures that we put into place that help us not remove the threat entirely, but reduce the risk of the threat, Rahul.
Okay, got it. I'll open the floor to anyone who has any further questions. I think so far nothing.
Tim, what I did want to say, you can find me on LinkedIn. The name's Amir Shamiri. So if there's anything that you want to ask offline, you can reach out to me on LinkedIn. You can reach out to me at Mend as well. If you want to find out more information about Mend and who we are, just go to mend.io. That gives you a great understanding of what we do, how we help with the problem of application security in the AI native landscape. And again, Renovate is open source. So if you're looking for a method to be able to update your dependencies in an automated fashion, install it today. Jump on that sort of approach of being proactive with it with the AI usage and have the actual fixes being automated for you there.
Got it. So so you used to be a developer before, and now you've transitioned into this kind of role. So what do you think, 5 years or 10 years down the line? So a lot of people are saying like software development or like, like a developer, the role of a developer will just end. Is that something that's going to happen or?
So it's a very difficult question, Rahul, right? Because the code that's being generated by AI, yes, we're going to end-to-end code creation, testing, completion, all of it's being done now by AI, right? But we still need humans to manually review. I think we're still a way away from getting rid of developers because with developers comes expertise, skills, knowledge, and that's what we're missing at the moment. That's why we're seeing security problems within AI generated code because of that knowledge gap. So 5 years, 10 years, we may have a new role as a developer where we are training, we are instructing AI on how to behave. We might not be writing code ourselves anymore, but I think the knowledge and expertise is invaluable. You can't take that physical being in front of a keyboard, writing code, that knowledge and skill. An AI agent doesn't have that, right? They're just trying to think, oh, Amir's told me to create some code. What do I need to do? Okay, quick, bang, 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 bang. And it tries to create something for you.
Mhm.
That logical thinking of, here's another way to think of this problem. That's only coming with experience. And I think that's something that AI doesn't have yet. So I think developers were still safe, but adapt, right? If you're not using AI right now to help you with your code generation or your actual development journey, I think it's a good time to start because if you don't start to adopt AI in any industry, we're going to be left behind. It's the way of the future, right? We need to adopt AI to be able to propel ourselves forward. It's a vehicle to help us to get to the next level. And I think that's what we need to do, whether we're a developer, whether we're testing, start to use AI within your role so you can figure out how it can impact you in the most positive way.
Got it, got it. And so one more thing, how so you touched upon the topic of managing, first of all, knowing what the attack surface is, and then of course managing that attack surface, right? So what kind of basic controls can an organization implement so that this the attack surface is minimized, especially
Great
with
question.
AI, right?
Great question, Rahul. Yeah. So obviously we all remember DeepSeek, right? It appeared overnight, it was phenomenal, but a lot of people were very skeptical about using it because of its ties of where it originates from, because of what the technology could do potentially in the background, right? So now that you know that you're using DeepSeek within your actual application, why not have a policy in place that says if the author is DeepSeek, I want to block it, right? Having that governance piece that says what's okay and what's not okay based on organizational risk, right? What do we want to do if we find a malicious model? Do we want to block it? Do we just want to notify about it? What do we want to do if we find conversational AI? If I know my chatbot is speaking to a human, my attack surface is increased because now there's a person here that can communicate with my AI and start to potentially exploit it. So once you understand what you're doing and how the dots are connecting, you can then figure out, okay, all right, if a human speaking to the AI is prompting it, that's susceptible now to prompt injection. I need to now have security measures in place for that. If I'm using DeepSeek's model, maybe that's a bit of a security risk. I might want to put a blocker in there so I can't release code if it's got DeepSeek in there, right? You now can understand what you want to do moving forward with the identification piece. If you don't know what you don't know, you can't have any security measures. That's why an AI bill of material is so important, Rahul.
Got it, got it, got it. And you also touched base on the guardrails. So a lot of people, especially like malware as SaaS and using AI for cyber attacks, and also there is like this huge market, especially in like this like the dark web and all, where they basically are creating use cases so that they can bypass these guardrails. So as we're
Hmm.
setting up the guardrails, the other side is already, they already know how to like leap front of on top of the guardrails and just get in anyway.
Yeah, yeah,
So uh,
yeah.
like this speed is always like just ever increasing. So is AI versus AI like the only way, or
Unfortunately, I feel so, right? As you've said, guardrails come into place. AI is trying to figure out ways to jump over that guardrail. So now the guardrails
yeah,
have to use AI to try and figure out how to block it, right? That's why you need to pick a partner in whoever you're using with the security guardrails in place, all the security tooling that's continuously adapting. If we create a approach today, it probably won't be relevant in 6 months' time because things have moved forward. Because as we've seen, the time to exploit is just shot down. As in, we're getting exploits within minutes, right? It's incredibly crazy right now, right? So we need to adapt. We need to make sure that we've got things in place that are adapting with the security measures, just as we are with the security attacks. Attacks are increasing. Well, our security measures need to increase as well. We need to adopt the way we're thinking and we're working to pick up on these actual adaptations. So we're looking for them so we can actually protect from them.
got it, got it. And even in the attacks, there are a few different kinds, right? So that there might be a disruption in your service. There might be like something that's causing like a single point of failure. There might be
Mm-hmm.
something that's trying to exfiltrate your IP, or like basically like the bread and butter of your company, or like the treasure of your company. So
There we
there
go.
are
Yeah.
very like so many different like cases where
Layers.
which
Yeah, yeah.
which layers which you need to be protecting. So when it comes to risk also, how would one try to like quantify or measure all of these? First of all, like categorize that, oh, these are the classifications of risk, and then try to measure these things. So like how would that also be possible?
Very, very good question, Raul. Obviously, there isn't a one size fits all, right? Different organizations have different risks that are inherent for them, right? So, first and foremost, you need to think about how your risk is working for your organization. What attack vectors do you have? Because we can't just have one solution that's looking after everything, right? Guardrails look at the interaction, right? That's great. You've got WAFs, which try and protect the actual network and infrastructure. That's great, right? But there's different security problems, right? If we have a chatbot, we've now got prompt injection, right? We've got data exfiltration that can take place. The actual code itself, if it's using AI, we can now exploit the code because it's using AI. So I think the first part is, again, I'm going to say this again, understanding what you don't know. Because if you don't understand how you're using AI, how can we protect from it? So I think the key here is first figure out how are you using AI, and then try and backwards sort of break down exactly how the AI can be exploited within your organization, right? So, for example, if I have a chatbot, that's an attack surface that I didn't think of before, I might need to do red teaming on that to make sure it's protected and it's working in the correct way. I would say do your research, right? Don't try and jump into something, but also don't delay. Try and fix the problem before it becomes a bigger problem. You don't want to wait for a data breach before you're actually fixing a problem. You want to be proactive. So figure out your AI bill of materials. What are we using? What's in our architecture and infrastructure? And then based on that, let's go ahead and start to implement some tools, whether it's open source or paid. That's completely up to you, but you need to start today.
Got it, got it. Now, I think one last one. So we've talked a lot about enterprise AI. So as an individual, like, what should an individual like you and me, what kind of basic protection that, or like a navigational tool that that we should use, where we should and where we shouldn't use.
Yeah. Great question. So I would say, first and foremost, you should be still having the traditional SCA and SAS methods in place, right? Because we know that AI is being used to create code, so we still need to protect it. So I'll say, first and foremost, make sure that you're scanning your code, right? That's the number one thing I would do. Again, whether it's open source, whether it's paid, just scan it, right? Knowing 50% of what could be the problem is better than knowing nothing at all. So start scanning from today. Then look at automation. How can we actually scan the actual code that we've written to look for automations on dependency updates? Look for automations on potentially the security flaws that we found there as well. OWASP has dependency tracks, for example, where you can start to understand sort of what's going on in the open source landscape of SCA there. So look at the open source tooling and see what you can do, right? You don't always have to pay for a solution to have a solution. You might just need to look into the market and start researching. But the one thing I hope you take away from this conversation today is you need to start having these conversations internally, right? If you don't have these conversations, you can't build a plan to move forward. And it all starts with having that uncomfortable conversation of saying, how can we be attacked? Think from a hacker's perspective. What mitigations do we need to put into place to stop an attack from taking place?
Got it. Got it.
Again,
I
thank you
think,
so much, everyone, for
yeah,
joining.
thank
I
you
just
so
wanted to
much,
say, if you did
Ross.
want to
Yeah.
reach out, yeah, if you wanted to reach out, again, LinkedIn, drop me a line. I'm more than happy to assist and help with any way we can.